welcome you to my lecture today. Of course, today I'm actually going to walk you through another exciting statistical topic. Of course, we're still working on logistic regression model. We started that a few days ago. In today's, the focus is going to be on logistic regression with categorical predictor. At times even though we know the response variable is categorical, we can also have a situation whereby one of the predictor is categorical as well. In that kind of situation, how do we interpret that? So that will be the focus today. In the outline, analysis of categorical variables. Because why do I say categorical variables? The response is categorical. One or more predictors also categorical. And how do we interpret that? And I'm also going to talk about case control study. We started working with this example on Monday, where we are actually considering some factors that determine getting admission into graduate school. The response variable here is categorical, yes or no, whether you're given admission or not, subject to some predictor variables like GRE, GPA, and school rank. We know the GRE and GPA are continuous predictors, but school rank is categorical. And categorical variable has levels. This from level 1 to 4. 1 is highest prestige, and of course 4 indicate the lowest prestige. Of course, the prestige of undergraduate institution actually matter a lot when you apply to graduate school. Now you can see the data set, but there's something I wanted to pay attention to under admit. You can see 0, 1, 1, 1, take a look at that. It means the level of the response was cut, since we got 2 levels for that, we're going to indicate 0, 1. You can now decide on the one you're going to put, you're going to indicate 0, the one you're going to indicate 1, most of the time. Depending on what we put in the numerator, if I'm considering the probability of yes, I think my leg is fantastic now. If I'm focusing on the ratio of probability of yes to probability of no, where I'm considering the log of that equal this guy, maybe up to BPXP plus the error. If I'm talking about this guy, if I have yes here, I have no here, then I'm looking at the probability of yes relative to no. It is better we code yes as 1 and no as 0. So that by the time you obtain your probability, which is going to be, by the time you get that in probability form, okay, where you have this guy, divided by 1 plus this guy, this is the interpreting this will make sense. Because this guy is proportion or the probability of yes of the one you have in the numerator, not the one you have in the denominator. You're focusing on this guy. Now, do you know if I code yes as 1 and I code no as 0, if this guy is very close to 1, it means it's very close to yes. It means the probability of you being admitted, the probability of them saying yes, we will admit you, is going to be very close to 1 because you've coded yes as 1. Does that make sense? But if you do it the other way around, you put no here, you put yes here, your decision will be on no. And in that situation, no will be 1, yes will be 0. Which means if pi is very close to 1, you know what I mean? That will favor you not being given admission. So what am I trying to say now? You need to be able to decide out of the levels of the response that I have, which one am I going to code 1? Which one am I going to code 0? That is very, very important. Okay, now, as you can see in the table, you have admit 0, 1, 1, 1, 0, 1. If you take a look at this table, you're basically going to see that that very 1, nobody can tell which one is coded as 1, which one is coded whether yes or, but you can just say, okay, oh, 1, somebody have a 800 GRE and 4.0, and that person come from the highest prestige. Of course, that person will be given admission. We're expecting that 1 to be yes in this data set now. Now 1 is yes, 0 is no. Does that make sense? But if I'm going to give you this in exam, I'm actually going to tell you what I code as 1 and what I code as 0. Does that make sense? Okay. Now, if you based on rank, because rank is categorical, we generate a 2x4 table. You know, when you take a look at the 0, that will give you the number of students from each rank that was given admission and the number that was not given admission. Okay, now if I run a regression now on that, where I'm actually regressing admit on GRE, on GPA, and on the rank, where I indicate family called binomial, I'm actually going to have these regression results. The regression result that you can see, GRE is significant, GPA significant, rank significant. Of course, you know why we have rank 2, 3, 4. Rank 1 is reference. Arrow has automatically referenced that. And the estimate that you see, we call that log odd estimate. Log odd, don't forget, log odd estimate. Now, this is just trying to compare 2 modules. The module 1 is admission does not depend on any factor. That's an intercept module. Module 2, oh, admission depends on GRE score, GPA score, and rank. And you actually use ANOVA test for 2 modules, indicate test to be chi-square. You have a p-value given that. Of course, when you have a p-value like that, you're actually rejecting the simpler module. It means we are actually going for the complicated module. But how do I interpret? Okay, interpretation is very, very important. in logistic regression, my interpretation is going to be based on two different things. I can interpret based on log, odd. I can also interpret based on odd. Based on log odd and based on odd. Now, when you take a look at what you see from the table, negative 3.99989979 is 0.002264 up to negative 1.551464. They are log odd estimates. If I were to interpret each of that, particularly I want to interpret GRE. Look at what I said. For every 1 unit change in GRE, do you see what I said? The log odds of being accepted. Why do we say of being accepted? Oh, in the numerator, they are considering yes, accepted over rejected. Does that make sense to you now? And that was why I say the log odd of being accepted. Then you are actually emphasizing what you have in your numerator, not your denominator. So you're going to say the log odd of being accepted versus not accepted. That means the numerator is accepted divided by not accepted increases by 0.0022. You can see when I was interpreting that, I measured the log odd because 0.022 that you see for the GRE is a log odd estimate. Okay. Now, that is how to interpret the log odd estimate for GRE. But how do we interpret the odd for the GRE? Then you need to first exponentiate the log odd. When you exponentiate the log odd, you're basically going to get odd. That's what you can see now. Exponential raised to power that log odd, because you know why? In mathematics, if I have log of x, right, and exponential raised to power that, okay, is basically going to be x. This for mathematics. Okay, the exponential raised to power log x, okay, is the same thing as x. But the log that I'm talking about is a natural log. Okay, is a natural log. So exponentiating that actually give you 1.022. The 1.022 becomes odd, not log odd anymore after exponentiation. How am I going to interpret that? A unit increase in GRE multiplies the odd of being accepted by that particular value. Odd of being accepted. And the same thing also goes with every other one. But how do we interpret? You know, the same thing go with the GPA. But how do we interpret the categorical predictor rank? If I were to interpret rank, there are two things to interpret. Please take notes: log odd and the odd. If you take a look at the rank that show up in the table, rank 2, rank 3, rank 4. There's no rank 1. The rank 1 is reference. If I'm going to interpret rank 2, that will be relatively to rank 1. If I want to interpret rank 3 relative to rank 1, rank 4 relatively to rank 1. Take a look at my interpretation now. Having attended an undergraduate school with a rank of 2 versus an institution with a rank of 1. If I mention a particular rank, I'm going to be saying versus the one that was referenced. And I said, you know, that decreases the log odd of admission. I'm still talking about log odd admission, decreases that. I'm going to go back. Why am I talking about decreases? I'm talking about decreases because the log odd estimate of rank 2 is negative value. And that was why I say decreases. If it is positive, I'm going to say increases. That was what I mean. If I exponentiate that, that will give me a value for odd. And I will be able to interpret odd. When I exponentiate negative 0.675, that gives me 0.5092. Okay. And I want you to take note of this. Is 0.5092. How can that be interpreted? That value will be an increase for admission. Okay. Now, when you take a look at, but it's going to be, if you take a look at it, say, this is a decrease. Sorry, why do I say decrease? If you go back to that's all the rank 2, 3, 4 is negative, negative, negative. They are going to be decreases when you are interpreting that. Whether you are interpreting for log odd or odd, they're always going to go in the same direction. So we take a look at that now. You know, we have a 0.5092, and this is a decrease of 49.1%. How do I know a decrease of that? If I multiply a 0.5092 by 100, that's less than 100. Because it is less than 100, it's a decrease. If it is over 100, that would be an increase. And do you know what? Exponential of a negative, okay, will not give you something that will be over 1. If it is positive, of course, it will give you something that will be over 1, that you multiply by 100, that will be more than 100%. That we can call it an increase. Okay. We want to go into a different thing now. How do we test? Maybe we want to have a test on rank. Go ahead. How do we tell from the output as a log odd? Because do you know, that's a very good question. But the formula we use that gave us those results, this is what we program. We program a log odd. We program this. Does that make sense? So this is what we actually programmed. So our module that actually results in this output, this is what we coded in R. We coded a log of odd. And that is the reason why whatever that you see in the values of the estimate, this guy here, they will be called log odd estimates because of the fact that this is what we coded. Then we automatically, when we're dealing with a logistic regression, it's always going to be log odd estimate because we program the log odd function. That's a good question. And if you want to answer a question that has to do with odd, it's more or less like removing this guy. But what is a mathematical way to remove this guy is to exponentiate. Does that make sense to you now? That question is fantastic. Have I answered your question? Okay, go ahead. Exactly. No. This one automatically They are called log odd estimates. Why are they called log odd? Because of this. Okay, this is what happened. The moment you specify, can you look at the code? You are using GLM, right? And you specify family binomial. It has automatically will do that for you. Do you know funny thing? If you don't put family equal to binomial, you will get a linear regression result. And getting a linear regression result, that is not a log odd. That is just an estimate. That's another beautiful question. I've answered your question now, right? Okay. Now, what am I doing here? I want to test. If you take a look at the first, when I install package AOD, okay, but I'm looking for opportunity to test among the schools, among the school rank. How many levels of how many levels of school prestige do we have? We got 4, right? I want to see whether there's a significant difference between them. Then we conduct it, a WAT test. That's why I call a test of rank. And that test is chi-square test. What happened? The p-value is 0.00011, which means there's a significant difference between the rank, the rank 1, school that have high prestige, lowest prestige, and so on like that. What am I doing here? Oh, I know different exists in the rank, in the levels of rank. Oh, does the difference that exists, does it exist between rank 3 and rank 4? You remember in analysis of variance, when you are contesting whether there's a significant difference between 2, 3 or more independent group, if you have rejected the non-hypothesis in ANOVA, what do you do next? You do go for multiple comparison, right? You want to know where the difference lies. Now there's a difference here between the ranks, but we don't know where the difference lies. Or the only thing we know that difference exists in the 4 levels of rank. Now, do you know what I'm specifying now? Is there a significant difference between rank 3 and rank 4? I can do rank 1 and rank 2, rank 1 and rank 3, different kind of, but here I'm interested. If I'm interested in that, what am I going to do? I wanted to take a look at what I'm going to do now. Look at the matrix. Okay. Some of you will see in the matrix, I got 0, 0, 0, 3, 1, minus 1, 0. Look at that. If you look at the matrix on the board, okay, if you take a look at this, that is for the rank. Okay, rank 1, 2, 3, 4. The rank that I'm comparing, let me see, on the board, 1, 2, 3, 1, minus 1, and then 0. Okay, yeah, so 3 and 4. Oh, sorry, 3, 4. Now, when you take a look at what I have, no, not the other one. I think the way I wrote it before. Sorry about that. So that would be 0, 000, 4 zeros. Then I'm going to have 1 minus 1. So let's say this is rank. So 3. This is to be 4, 3, 2, 1. And I have rank. I also have the GROE and the GPA. I'm not interested in these ones. All these are predators, right? That are used in the model. I'm not interested in this. I'm only focusing on rank. And even within the rank, I only want to compare rank 3 and 4. Do you understand this one now? Does everybody understand that? That is what I'm specifying. If I want to do rank 2 and 3, it's going to be different. For rank 2 and 3, for rank 2 and 3, this is where I'm going to have 1 and -1 here. Please take notes. So that is what I specify. I want to test do we have a significant difference between rank 3 and 4? Okay, that's why I'm going to say 1 and -1, and that gives you 0.59. It's 0.59. What does that mean? The p-value is it's larger than 0.05, which means there's no significant difference between the school that is ranked 3 and 4. That's what it means. Okay. Now, do you know what I want to do here? I want to predict probability for each rank given the same GRE score and GPA. Now, this is it. Look at this guy. This guy applied to graduate school. Okay. This guy also applied to graduate school, right? The GPA, the GRE of this guy is 587.7. This one also has the same GRE. The two of them have the same GRE score, the same GPA, two of them, the same. Do you know the difference between them? This one attended a different school. They attended, different schools. Now, when you see, if you take a look at what you have on the board, I have 4 candidates. The 4 of them have the same GRE and GPA. The 4 of them. That's why at times somebody will say, oh my God, I got the same GRE score and the GPA score with this guy. He was choosing and I was not choosing. Why? The reason for that is because of the fact that you have your undergraduate school have different prestige. This one comes from undergrad for prestige 1, prestige 2, prestige 3, prestige 4. Look at what I put on the board now. They got the same GRE, the same GPA, but different schools in terms of prestige. Now, we now calculate the probability. The code that you see now is calculating their probability for them. Let's see what we got. Oh my God. When you go to school with prestige 1, that is rank 1, okay, is 0.516. If you took that to 2 decimal, it means 52% for students graduating from rank 1 undergraduate school, 35% for rank 2, 22% for rank 3, 18% for rank 4. Does that make sense to you now? What distinguishes between these students is just the school they attended for undergraduate. They got the same GRE, they got the same GPA. How do I show that? In a plot. This is a code. You can try all that code. And this is it here. What am I doing here now? This is like plotting the probability of graduate school admittance against the undergraduate GPA for different school rank. You can see their intercept is not the same. Oh my God, take a look at this now. The intercept of number 3 and number 4, looking closely. Do you see that? Do you see that? And that was the reason the other time here, when we are testing whether difference exists between them, we fail to reject the null hypothesis. Look at the 0.59. Difference doesn't exist between the rank 3 and rank 4. That is what I'm also seeing in the graph now. We are very, very close. Okay. Now, if you look at the effect of the rank on admission only, do you know what I'm doing here? This is what we call analysis of categorical variables. The response is categorical. Predator is also categorical. This is what we call analysis of categorical variable. Here now, I'm only interested in what is the effect of rank on admission. I'm not talking about GRE. I'm assuming that they all have the same GRE and GPA. But what do you see? Rank 2 is significant. Rank 3 is significant. Rank 4 significant. Do you know intercept is rank 1 here? Yeah, the intercept you see here is rank 1. Okay. Now, the cases who have the disease and those who do not have, and from the two groups, we are asking them the same question. Are you exposed or not? Some are going to say, I'm exposed. Some are going to say, I'm not exposed. I'm going to ask that from the two groups. That's what we call case control study. Now, what I want to do now, I will now generate a table. I will generate a table. I'm going to have cases control. I know the number of people I selected, right? That have the disease. Do you know the total number of people that have the disease? A plus C. Do you see that? A plus C. The total number of cases would be the number of people I identify in the community that have the disease. B plus D would be the number of people that do not have the disease. Okay? Now, A plus B, look at the row, A plus B, the total number of people in the two groups that are exposed. Some can be exposed to the disease and they don't have it. I mean, they could be exposed to a particular risk factor, they don't have it, and some can have it. What about the unexposed? Okay, some are not even exposed, they have it, okay, and they don't have it. Now, what is the meaning of A? Oh, A, the number of people that are exposed and have the disease. That is A. B, the number of people that are exposed but do not have the disease. C, the number of people that are not exposed but they have the disease. D, the number of people that are, they are not exposed and they don't have the disease. How do I find the odd? Then I want to find the odd ratio now. Because why am I finding the odd ratio? Because I actually want to test. I want to test if the odd ratio is equal to 1 or not. Okay. Now, I'm actually going to do the odd of exposure among cases. And I'm calling that those who have the disease, the odd of exposure, I'm actually calling that 1. Divided by the odd of exposure among control. How do I find the odd of exposure, okay, among cases? That would be A over C. I'm talking about cases, okay? The odd among cases is going to be I'm exposed divided by I'm not exposed. That's why you see A over C. I will do the same for control. For control, I'm exposed divided by I'm not exposed. That will be B over D. Then I will now do the ratio of that. That will give me the odd ratio. But what is interpretation? When odd ratio equal to 1, then we are trying to say the odd for the disease is the same for the two groups, whether you are exposed or not. Then with that, you cannot claim that your exposure lead to disease in that situation where your odd ratio equal to 1. There's no linkage. If people in a particular community where there was environmental hazard, the only way they can prove to government, okay, that they are affected, if you conduct a test like this, if odd ratio equal to 1, then the government is going to say that didn't affect you. Does that make sense? Okay, now take a look at when the odd ratio is greater than 1, then exposure increases the odd of the disease. Do you know what those community want? They want the odd ratio to be greater than 1. So that they can say that, oh, it is because we are exposed to that increase our odd of getting the disease. And when the odd ratio is less than 1, then exposure decreases the odd. In fact, exposing to something decreases the odd of the disease. then I'm going to like this kind of exposure. Then if exposure can decrease, having disease, I like that kind of exposure. But the one I don't like is when the odds ratio is greater than 1, where the exposure will increase the odds of the disease. Take a look at that. And we got an example here. I'm going to interpret that example before I go. Of course, I'm going to continue from page 22 on Friday, which is going to be the last day of this topic. Next week is going to be revision. Oh my God. My class for next week are very, very important for everybody. The final exam will be loaded. You have 2 hours. It'll be loaded. There's going to be multiple choice. I'm confirming that to you. There will be a combination of multiple choice and, the short answer. You are writing it for 2 hours, but I'm actually it's going to revolve between 3 major areas, whether multiple choice or essay, 3 major areas: principal component analysis, repeated measure, and logistic that we're doing. Does that make sense? Revolve around the 3 major areas. Now let's take a look at this before I go. Oh, no. My time is up. Okay, I'll start from here on Friday. Is there anyone want to ask? Oh, I think there's a question in the chat. Will the exam have an online option? Oh my God. The only condition under which I'm actually going to allow online is going to be based on medical condition. I want you to pass and I want you to be here in person. Does that make sense? But in the case of a serious medical condition, I think you need to write me. Or maybe you have an important travel or whatever. Please write me before I'm going to approve online exam for the final. If I don't approve online exam for the final and somebody come online, I would never honor that. Does that make sense? But I want students to pass. Thank you so much. Make sure you stay. Oh, go ahead. Okay, well, there's going to be 15 multiple choice and 3 essays. The 15 multiple choice will revolve around the 3 areas the essay will revolve around. Does that make sense? 15 multiple choice question and 3 essays. All the question revolving around PCA, repeated measure, and logistic regression. Does that make sense? So all of them will revolve around that. I've answered a question, right? Okay, any other question? Go ahead. Is it Wiley? Oh, what I'm going to do on a nomogram, this class supposed to be the location, but at times when the semester is progressing, we normally have enrollments. So I will check that today and I'm going to put the information on the canvas, whether it's going to be in this class or not. You're going to know that today. Does that make sense? Any other question? Any other question? Make sure you stay safe. My leg is fine now, okay? Make sure you stay safe and have a very good day. Bye for now, everyone.